Hello, my mathematical lovelies, and welcome to another adventure in algebra. Today, we're going to be talking about specifically looking at the graphs of quadratics and how that can bring us into a new form of equation. So as you'll notice, I'm on the grid again today. We're going to do quite a bit of graphing and identifying different characteristics of the quadratic graph. So just to remind you a little bit of forms that we've seen before, we've been using standard form for a quadratic for a bit now. Oops. Which was, let's use Q for quadratic. That seems like a good idea, right? Ax squared plus bx plus c. And in the last three sections, or two sections really, we've spent some time looking at how A, B, and C contribute to finding solutions to the quadratic. So what we're going to focus on today is a little bit more of the visual and characteristics that we're going to see of the quadratic. And some of these you've already seen before, but some of them will be new. So the new form we are going to be using is something they call vertex form. And because I lack creativity, I was thinking about calling this V, but I'm going to call it Q because I want you to stress that these are the same idea, same equation, just written slightly differently. So we're going to have it be AX minus H squared plus K. And I'll talk to you a little bit about what H and K actually are and what they mean here in a second. But the first thing I want you to notice that's very important is these are the same number. And I'll tell you a little bit about what A means. Same A. So this constant out front, that A value is, the same value in both of these forms of the equation. We're just going to be essentially writing it differently. So let me take 2 seconds to do an example for you. So I'm going to take an equation. F of x equals 2 times x minus 1 squared plus 3. So this is in vertex form. We're going to write it in standard form. So you'll notice the positioning is exactly matching this whole Q of x. I've got the value of A as being 2, my H is 1, and my K is 3. So there's something going on here with how this looks. So I'm just going to take this and write it in standard form to show you these are going to be the same equation, just written slightly differently. So how we would do that conversion is we would just expand. So I'm going to square, then multiply by 2, and then add 3. So I'm going to just be expanding and simplifying and combining like terms. So rather than doing x minus 1 squared, I'm going to do x minus 1 times x minus 1 because that's what squaring means. I'm going to multiply whatever is being squared by itself. So I'm going to go ahead and FOIL this. So I'll do my first, x times x is x squared. I'll do my outers, so x times negative 1 will give me a negative x. My inners, negative 1 times x will also give me a negative x. And then my lasts, my negative 1 times negative 1 will give me a plus 1. Don't forget that plus 3 at the end. Let's go ahead and distribute in that 2. So I'll multiply everything in this by 2. I should probably, actually before that, let me combine like terms because that'll make this simpler. So I have x squareds and I have 2 negative x's and a plus 1. There we go. So now I'll distribute. Woohoo! So I have 2x squared minus a 4x plus 2, and then I have a plus 3. Okay, let's combine what we can. So the only things that are like are things with the same variables to the same powers. I don't have any other x squares. And looking at my terms, I have an x, but no other x's. The only thing I have that we can combine here are the constants at the end because they are the ones that have x to the 0 power, or no x's. So plus 5. So I've taken something that was in vertex form and I've changed it into standard form. So it's just writing it differently. These are still the same equation. Okay, so just as a reminder, we did graph these in the past, and we're going to make a connection between what vertex form does and what the graph looks like. So if you remember, previously we would graph by point plotting. So what we do is we make a table of x values and y values, and we would plot them and we would graph them. So I'm going to write my two forms of the equation that we had earlier. So we had f as 2 times x minus 1 squared plus 3, and we have the other version of it too, 2x squared minus 4x plus 5. So we're going to graph this really quick just by plotting a couple points and then sketching it. And I'm going to make some connections here between what these forms are telling you and what the equation looks like. So I'm going to move this up just a little bit. Hopefully you have these two plotted from earlier and you remember how to do point plotting. I'm going to pick the x values specifically to show us some things. So again, I am picking these x values because they're going to show me what this graph looks like. So -2, -1, 0, 1, 2, and I should have made my table a little bit bigger to fit in 3. So I'm just selecting, okay. So what you would do at this point is you would plug those values into f to see what you would get. So first up, I would plug in -2 for x, subtract 1, that would give me -3. I'd square that to get 9, multiply by 2 to give me an 18, and then add 3 to get 21. Now, if you want to write these all out and calculate them, you can. I'm just going to go ahead and write them really quick. Hopefully you remember how to do this. Actually, let's do at least one of them. Let's do f of 1 because this one looks pretty simple. 2 times 1 minus 1 squared plus 3. Now you could have also plugged it into this equation and they'll be the same. I erased everything. That was bad. Sorry. Sometimes the eraser is a little more touch sensitive than the rest of it. Oops. So 1 minus 1 you know to be 0. And then, or sorry, 1, when you take away 1 will leave you with nothing, aka 0. When you square 0, you get 0. When you multiply 0 by 2, you'll get 0 again. So this just comes out 3. So if you need to like hand do a couple of the values, that's good. 5 and 11. Let's graph this really quick. So I'm hopefully leaving us enough space over here to where we can graph this. I'm going to zoom out a little bit so I can get a couple more squares in here and get us to fit everything on one page. If you need to write your graph below, that's okay. I'm going to put in my axis and hope that it's big enough. And I did enough tick values to where this is going to fit nicely. So I'm going to do this by the scale that it should have so that it matches and we get everything to scale. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I'm not going to fit 21 on there. Oh well, hopefully that's okay. If you want to scroll up further and get 21 on there, you can, but we're going to make this work. So the first point I'm going to graph is 0, 5, so that's going to be right here. And then I'm going to do the positives and then I'll do the negatives. So the positives, at 1, you are 3. At 2, you are 5 again. And then at 3, we are 11. So remember, this is the x-axis, this is the y-axis. Should have said that earlier. Whoops. At -1, we're 11 again, and then at -2, well, we're off the scale. So hopefully you're getting a good vision of the parabolic arc that you get from a quadratic. Cool. Now what we want to do is we want to make some connections here between the graph and what's going on with our two forms of the equation. So in particular, one of the things you'll notice is that, oh, well, the value of c appears to give me the y-intercept. Now why would that happen? Well, because f of 0 is going to put 0 in for every value of x and leave you only with this constant at the end. So essentially, you should recognize that, oh, it appears that if I want the vertex, I should just look at the value of c in standard form, and that will help me find that point every time. There's something else on this graph that hopefully you recognize from the form as well, and that would be the value at the bottom of this arc. 1, 3. The bottom of the parabola. This is what's known as the vertex. The vertex, hopefully you see showing up in the vertex form of the equation. 1, 3. It's the value of h and k. So let's make note of what we're seeing so far. So in vertex form, so our vertex form, I love it when I start to write and it just does the dots and you guys can hear me hitting the screen and then nothing happens. F of x equals a x minus h squared plus k the point HK, trying to make my H's and my K's look really different, is called the vertex. Now we can see that the vertex for this one is the lowest point on the graph. But I'm going to write the two versions of this. Hopefully you remember we also have parabolas that will open the other direction. They open downwards, the other way the hoop can face. So this is either the lowest or the highest value. I shouldn't say highest value, highest point on the graph. Of f of x. So what's interesting about that is if you remember something about how we can tell if the parabola opens up or opens down, we hopefully remember that, hey, if the value of a is positive, we get something that opens up, and the vertex will be the smallest value, like what we saw here. Oops, I zoomed out again. Or minimum. So it'll appear at the bottom of the parabolic arc. And if it's negative, then we have a parabola that opens downward. And then the vertex is a maximum. So we're going to use that a little bit later, actually in the next section, to solve some problems. Because you can find the maximum value of some stoofs and the minimum values of some stoofs. Now, if you remember when we were actually physically in class rather than being an online recording, I did some funky hand motions to help you remember this. Remember hands to the air or hands to the end. We also think about this in terms of end behavior and what this would look like. Remember when you have something that has a even degree, my end behavior has to point the same way. So either my parabola's ends are going to both go up or they're both going to go down is another way to think about this. So that's what vertex is helping you do. It's helping you determine shape of the parabola from just looking at the values on it. I look at A, H, and K, and I immediately suspect what shape we should see. And then I want to note one last thing that we already said. And for f of x equals ax squared plus bx plus c, we know that 0c is the y-intercept. This is not going to fit. That's the problems I have in my everyday life. I can't get things to fit. Make it work. There we go. Good times. So you could see why people prefer vertex form, because look at the list of information that we're able to get off it. There's like, oh, I know what it opens down, and I know that this part is going to be the top one, and I know that's going to be the bottom one, and I know what direction it's going to face based on A, and like I know the highest point and the lowest point, and I have a vague idea of what the shape's going to be because they're always a parabola. And then from this one, I was like, I know where it crosses Y, and that's it. So if you look at the list of things you know from vertex form versus standard form, hopefully you recognize that vertex form gives you more information, and that's going to be why it's preferred. I'm going to write a little note on the side here. If you forgot what open up means, that means, hey, my ends both go towards the ceiling, and then there's my vertex, and then opens down is going to mean it goes this way for my parabola, and then my vertex will be at the top as a maximum. So just to keep that in mind. HK, HK, little shapes and things. Another way that I sort of remember this, if this is something that you're worried you're going to forget, this is positive, which means it opens up, and this is a smiley face. And then if it opens down, you're negative. Oops, I don't want to underline these, make you think it's less than or equal to. And then, you know, sad face, positive, happy face. You know, negative, sad face. Boy, this is something that hopefully you won't need too much therapy over later. I don't know. So what we're going to do next is we're going to use everything we know about the quadratic to sketch graphs of it. So you have technology, you can graph. There are more superior ways to do this if you want an exact idea. But what we're going to do is we're going to use what we can see from the equation to write everything we can learn about the parabola before we do the graph so that we have some idea what the graph should look like. And then you know if you type something in wrong, which is a little, okay, it's a little contrived. But graphing by characteristics help us recognize when things are happening. So we're going to graph a quadratic, the quadratics that I'm going to give you A, B, C, D. By finding, and we're going to find the following things. This is kind of a big list. We're going to identify the vertex. We're going to find the x and y intercepts. And then we're going to identify the domain and range. What you maybe haven't realized at this point is that actually we've done a lot with domain when it comes to the quadratic, but we haven't done anything with the range. But actually having this information that I've listed here is enough for you to tell what the range is going to be. So it should be a good time. Let's start out with something that's actually already in vertex form to help us out. Actually, nope, I don't want to do that one first. Sorry about that. I copied the wrong one down because, you know, if I didn't make any mistakes, I would be perfect. And who wants to be that? I wanted to start off with a simpler one to make things a little bit easier on us. Sorry about that. That's actually my second example, what I wrote first, so you'll see that one in a minute if you're anxious about what it's going to look like. Why did that happen? Oh boy. All right, so let's start off with, well, what I need to know. I need to know the vertex. So the vertex is the value of h and k. I'm going to write below this the standard form so you can see where the values pop up. So a x minus h squared plus k. So our vertex, why did that r end up so long? It looks weird, live with it, is the value of h and k. So for this equation, hopefully you see, what's in the position of h? It's a 1. What's in the position of k? It's a 4. So apparently my vertex is going to be hk. And out right below this, I'm going to write down the value of a. So since there's nothing in front of x plus 1, we're going to treat this as a 1. And it's positive. That means I know my parabola opens up. Make a little note there. That's going to help me do my shape a little bit later. Then next up, I'm going to find the y-intercept. So hopefully you remember y-intercepts are the place where x is 0. And so, because it crosses the y-axis, which means it moves up z and down z only, but no lefts and rights. So it has nothing for left and right, so it has 0 for x. That was kind of lame. I judge myself for that. So we're going to put in 0 for x, 1, negative 1 squared, plus 4. So when I square negative 1, I will get 1. So 1 times 1, which is also 1, plus 4, and it's 5. So that means when I go to graph my y-intercept, that is going to be the 0.05. Now the x-intercepts are a little bit harder, but I believe in us. And we've done these before, but it's been a while. The x-intercept are the exact opposite of the y-intercept. So to do the y-intercept, we had to put in x equals 0. So for the x-intercepts, we're going to put in y equals 0, or f of x equals 0. So 0 equals, I'm not going to write the 1, x minus 1 squared plus 4. Ooh la la. Now, if you remember completing the square, at this stage, all I need to do is solve for x. So I'm going to do some algebra. So I'm going to subtract 4. This was a completely bad choice for a problem, but that's okay. All right, so I've got something equals to a square. I'm now going to use the root property to solve this. So this would mean that the quantity x minus 1 is equal to the square root of negative 4, or x minus 1, oops, I gotta make space for this. Will it let me pick this all up and move it over? The answer is no, but it'll let me make a t out of it. I love it when this works. Oh, let's just do the plus or minus version. There we go. X minus 1 is equal to plus or minus the square root of 4. Woohoo! Now you could have done this with the quadratic formula if it was in the non-standard form. Or sorry, if it was in standard form, not in vertex form. It'd come out the same. Oh, it's negative 4, not positive 4. I'm making all kinds of mistakes all of a sudden. I swear. It's like a thing. Hopefully you remember when I do the square root of a negative, I rewrite it as the positive version of the root with an I. So this is going to be, and then the square root of 4 is 2. So this is plus or minus 2i. And then I'm just going to add my 1 over. So we get that x is 1 plus or minus 2i. So these are both going to be complex. This is going to have no real solutions. And that means it never is going to cross the x-axis. But there were some things that hinted at that before. So notice our vertex, which is going to be, since this opens up, a minimum, is completely positive, which means the smallest this gets is the 0.14. So that means it never goes down and touches the x-axis. So there's some things going on that hint at the fact that I probably shouldn't get any real x-intercepts off of this. Let's go ahead and graph this puppy real quick. So I'm going to have 1, 2, 3. 1, 2, 3. I gotta make sure I hit 5. So 1, 2, 3, 4, 5. 1, 2. Good enough. Remember, we're just sketching here, so it doesn't have to be perfect. So from the vertex, I know it has the 0.14, and it crosses at 0, 5. And I know it's got to have that parabolic arc behavior. So over, up. It's got to be nice and symmetric. Whee! Whee! Do you like it? Just a sketch. So again, no real solutions because never crosses x. And that's all she wrote for that one. Let's do another one of these because I think it'll go better with the second one. It's honestly probably the one I should have done first, but I changed my mind and now I regret it. Oh well, let's do B. Oh, so much judgment in this little room right here. All alone. It's awkward. Hopefully not for you though. So, quick little reminder, standard form, or not standard form, I keep saying that, vertex form, opposite of h, that looks like a k. See, that's what I was worried about. My h and my k's look kind of similar. If I put a little squirrely rotation at the top of the h, it'll be a little clearer who's k, because then it's got the circle down here. Cool. So as far as vertex goes, we're going to have to be a little careful here. So k minus 3 plus 3. So I'm going to do the opposite. So I'm going to rewrite this really quick. So I'm going to do this as minus the quantity x minus a negative 2, because a negative will make a positive. That's how I'm going to get this plus 2 in the middle. Squared plus negative 3. Because I want you to see that h and k are actually negative off of this one. So my h value is actually negative 2, and my k value is negative 3. Weird, right? So this one crosses as a negative. That's interesting. And then you note that your value of a is negative 1, which is less than 0. So we're going to downward this one, sad face times. So this is going to be the biggest that it gets is at negative 2, negative 3, and opens downward. Let's see what the intercepts are going to be to get some idea of what else this looks like. So as always, I'm going to do the y-intercept first because I think it's the easier one. I'm going to abbreviate that. Hope you're okay with it. So I got to do f of 0. Negative 0 plus 2 squared minus 3. Don't forget that negative out front. So we're going to square negative 2, or sorry, not negative 2, positive 2, and get 4. All right, and then, oh, I have that negative out front. So negative 4 minus 3 is a negative 7. So my y-intercept is the point 0, negative 7. Cool. Let's do the x-intercept. This is going to rely on us solving a quadratic. So 0 is equal to negative x plus 2 squared minus 3. The first thing I'm going to do, crap, this one's going to have a negative also. I'm going to add 3. This is going to have non-real answers also, because I'm going to end up with a negative. Okay. I'm a little disappointed in this one. Don't forget that negative out front. I just did. When I was writing these examples, what was I thinking? Regrets. All right, so I got this negative out front, so I'm going to divide by -1 to get rid of it. So I'll have -3 is equal to x plus 2 squared. As you may have remembered from last time, I'm now going to solve this using the root property. So x plus 2 is equal to plus or minus the square root of -3. The square root of -3 we're going to rewrite as the square root of 3i. I still have my x plus 2. Subtract my 2 over, and I get 2 non-real answers, so this is also never going to touch, which, again, we should have realized, or I should have realized, I'm negative, and I open down. I mean, what was I thinking? A bunch of non-real stuff. It's okay. My next couple don't have non-real stuff. I don't think. I'll have to flip the page to tell. Good times. Okay. All right. Yes, this next one will be better, I promise. I promise. Yep. So let's make a quick sketch of this guy's graph. Again, won't be crossing the x-axis, going to need lots of negatives. So I'm going to just go ahead and put my positive axis up top here. 1, 2, 3. 1, 2, 3. -3. +3. 1, 2, 3, 4, 5, 6. Oh, wait, 5. 1, 2, 3, 4, 5. Why am I having a hard time with 5 today? I don't know. Okay, we open down. Our vertex is at a resounding -2, -3. So -2, and then down 3, 1, 2, 3, right there, and it crosses at 7. 5, 6, 7, and then, so what I'm doing next here is I know this makes this side of the arc from the opening downness of it and having to go through and stuff, and then I'm making the reflectional symmetry point. So if you imagine drawing a line down here and then reflecting everything across that line, this is 2 away from that line, so that should lie there. It gives me this other side of the arc. There we go. So that's how I can get a second point easily, thanks to the lovely symmetry of the parabola. Esputumus. And again, just a sketch, doesn't have to be perfect. So that means if you went to a graphing calculator and you entered this equation in, and you got something that was opening up and in a different spot or didn't cross at -5, you know, that would be a good hint that you did something wrong when you typed it in, because we already know what this should look like. Let's do another one. I like this one because it's sneaky. It's never a bad idea to stretch your brain a little. Okay. So again, thinking in terms of vertex form, I'm going to rewrite this a little bit to give you an idea of what it looks like, so I can easier pick out what h and k are. So I got a perfect square here. It's actually x minus 0. Do you see it now? Ha 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 ha. My vertex is actually the point 0, comma, remember it's plus k, so this is going to be that my k is actually -4. So this has a vertex at 0, -4, but wait, be careful. The value of a here is the value in front of my square part, which is just 1. Also positive, so this is opening up. This one should cross an axis because its vertex is in negative land and it goes upward. This is supposed to be more of a parabolic arc, which means it should be symmetric on each side, and boy was that not. That was bothering me a little. Let's figure out our y-intercept. Hopefully you're miles ahead of me on that one. You're like, I plug in 0, and this time it's easy. 0 squared minus 4. Oh boy, minus 4. So that's going to be 0, -4. I am always running out of space. Let's do ourselves some x-intercepts. Now for fun, I'm going to do this 2 ways. Hopefully you recognize this lovely quadratic as something that actually can be written as a lovely pair of factors. It's the difference of squares. Cool. And then using the zero factor property, you can say, oh, well then x minus 2 must be 0, or x plus 2 must be 0. And that gives you the 2 points. Oh wait, gotta solve real quick. X is 2. Typo. Nope, come on, erase for me. There we go. Subtract 2. Because remember, if I multiply them and one of them is 0, that means at least one of them must be 0. The only way to multiply and get 0 is to have one of your factors already be 0. Aha, so this arrives me at 2 points. 2, come on, go away, eraser. 2, 0, and negative 2, 0. Lovely. Or let me show you another way to do this. Or you could have done this the way we have been doing quadratic solving up until now, using that root property. So you just add 4 to both sides, and you're like, oh, okay, well, x squared is going to be 4, which means that x is actually plus or minus the square root of 4. And the square root of 4 is 2, so it's plus or minus the square root of 4, which is 2, and I went to write the root again because fun. Nope, I want you to go away. Not you, though. You should definitely stay and listen. Aha, I get 2 solutions, 2 and negative 2. Let's sketch this bad boy. All right. Was that one kind of fun? I hope it was. We'll find out. So let's see, 1, 2, 3, 4, 5. Want to be clear, negative 5. 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5. Why is it that the pen doesn't always slide right? 1, 2, 3, 4, 5. There we go. I've got my scale going. Let's plot our points. So our first point we're going to do is our vertex, 0, negative 4. So it's going to be right here. And then I have my intercepts I can use from there. You'll notice that in this case your vertex is also your intercept, so that's something kind of interesting. Sorry, your y-intercept more specifically. They happen to be the same point in this case, kind of fun. And then we have the two x-intercepts of 2, 0 and negative 2, 0. So we'll just do a lovely little parabolic arc to cross those two. Look at that. Beautimus. That one's a little fun, I hope. Maybe? I don't know. Depends on who you are. All right, let's look at one more. I have lost track of what letter I'm on. I think I'm on D. I hope. X squared minus 2x plus 1. Or sorry, plus 2. Uh-oh. Emergency! Not in vertex form. Oh no, what do I do? The rather simple answer is, when you run into something that's not in vertex form, you need to turn it into vertex form. So the easiest way to change this into vertex form is to complete the square. So we need to complete the square. So let's go ahead and set that up to do this. So I'm going to want to make some space here. I got to find my missing value. Cool. Oh, not 2x, 2. So that's the 2 from over here. Cool. So I got to find my missing value. So if you remember how to do this, you're going to take the value of b, divide it by 2, and that'll give me a negative 1, and then I square it, what you get from that, and that's what you're going to add. So here's where you're going to have to be a little careful. So I'm going to add my missing value, and that's not okay, because I just added something into the equation, which will change it and make it different. We don't want to do that. So we're also going to subtract that value, so I keep everything balanced. Now, these three together will make a perfect square. And then I'm going to combine these two together to get a plus 1. And now I am in vertex form. Perfect. So now that I'm in vertex form, I can literally read my vertex right off this. So my value of, okay, I'm going to have to be careful. My value of h is 1, and my value of k is also 1. Okay, that's a little unusual. My a value is also 1. Since that's positive, that tells me I open up, which is a good thing. Oh, I hate it when it grabs stuff on me. Okay, let's go ahead and do my y-intercept. So I'm going to put in, oh, I can do this more easily. So since earlier up above I have the standard form of this is always just 0, comma c, and my value of c up here is 2. So I can just say, oh, it's 0, 2. Done. It's kind of fun. Let's do our x-intercepts. And like I keep telling you, there's lots of ways to do these. So since I have standard form of this, I'm going to do this a little differently. So I have x squared minus 2x plus 2. I am going to do this using the quadratic formula for fun, because that will also give me the x-intercepts. X equals the opposite of b, so b is negative 2, the opposite will be a positive 2, plus or minus the square root of b squared. So I'm going to take negative 2 and square it, minus, for a is 1, because that's the value in front of x squared, and c is 2, all over 2 times a. So I've got 2 plus or minus, I gotta be careful with my square root, okay. So I gotta square negative 2, that'll give me 2, and then 4 times 1 times 2 will give me 8. I always make this too big, I swear. All over 2. So 2 plus or minus the square root of negative 4 over 2. We're seeing where this is going. We're going to have some complex numbers here. So 2 plus or minus the square root of negative 4 we did earlier, that's going to be 2i all over 2. So this is going to be complex. I'm going to have no real roots, which is fine. We should have suspected that earlier from seeing plus 1 and then open up. So let's go ahead and sketch this guy real quick. So if you remember, my intercept is at 1, 1. Let's just go ahead and put that on there. Or sorry, not my intercept, my vertex. My intercept is at 0, 2. And that means using symmetry, which always goes through your vertex, that point's going to be over here. We're going to open up. Okay, so I just realized in all these problems I never did the domain and range. There's no way for me to cut that in. So we're going to go through, we're going to do the domain and range on all of them. So domain, well, hopefully one of the things you remember about the quadratic is it's a polynomial, so it works for all real numbers, which means it goes from negative infinity to positive infinity. Here's the thing that's new though, the range. The range, if you remember, is the possible y values that you can get. So looking at the vertex, the smallest it can be since this opens up, and my y values is 1. And then since these arrows go up forever, which means it continues on, my range, oops, is from 1 to infinity. So remember, y values, so 1 and up. Let's go back and do the domain and range on the ones that I missed. So we're going to scroll back up, and we'll do this one. Cool. So again, domain, it's a polynomial. All x's are going to work. That means my domain is negative infinity to positive infinity. And then my range, let's look at where our vertex is. Oops, shouldn't put these in until I know for sure what it looks like. My vertex is at negative 4, and it continues up after that. So the smallest this can be is negative 4, and it goes up to infinity since it opens up. Let's look at another one. Oh, the blue one. Ah, now notice this one opens down, so we're going to get some different stuff here. So my domain, always the same for polynomials. Every single value of x is going to work, so negative infinity to positive infinity. But my range, we're going to have to be a little careful here. So remember, range is the y values you can possibly get. This opens down, which means that the biggest it can get is the vertex, and the vertex appears to be in my y direction at negative 3. So the biggest this is negative 3, and it goes downward. So this goes down to negative infinity, and the biggest it is negative 3. Hopefully you're making a connection with what these look like and how they get positioned. All right, last one, another opened up one. Now, if you've been following along, at this point, I want you to pause, write down your answer for your domain and range, and then unpause to see what the answer is. So my domain, negative infinity to positive infinity, because every value of x can be squared and not squared used as a single value and then added together and combined in a good way. And then my range starts at 4, because that's where my vertex is. No, opening up means the smallest it can be is the vertex. So the smallest this is going to be is the vertex value for y, which is going to be 4 from looking at our graph. And goes all the way up to infinity since it opens upward, and these arrows means continues on from here. So we're able to do the range. We have never been able to do it before for a parabola, so I'm hoping you enjoyed this. And remember, when in doubt, try completing the square. I hope you've enjoyed this adventure into graphing quadratics. Remember, you always have technology at your hands with these, so you can check yourself. Hopefully me showing you lots of different ways to find the x-intercept tells you that there's lots of different methods you can use. Use the one you're most comfortable with. So if in particular you're like, oh man, I looked at her doing this one and I was just like terrified, remember, you have other ways to solve. So you also have completing the square. If you like that better, do it. If you prefer using the quadratic formula, awesome. Just make sure you put it into standard form first, ax squared plus bx plus c first.